We continue our unit on polynomials with transforming a cubic function. To begin, let's graph the parent cubic function. For my key points, let's use -2, -1, 0, 1, and 2. So when x is -2, y is -8. When x is -1, y is -1. When x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 8. Now let's graph this. So this is the graph of the parent cubic function. The domain and range of the parent cubic function is all real numbers, just like in the linears. The points in the table are the key points for the cubic function. You will shift the origin and use the key points as a pattern from there. When I talk about the starting point and how the graph changes, this is what I'm looking at. How does it move? From what you have learned regarding previously studied functions, tell what effect you think each of the following will have on the graph of the parent function. Well, before we begin, let's review the general function transformation, but with the cubic. Y equals plus or minus a, these are the stretch or shrinks, verticals, times plus or minus b, this is the horizontal stretch or shrink, x minus h cubed plus or minus k. Remember the h is right or left movement, and k is vertical movement, up or down. Remember the negative sign out front is a reflection across the x-axis. The negative sign inside the parentheses is a reflection across the y-axis. Also remember that the horizontal movement, the stretching and shrinking, and the right or left movement is opposite of the way we think. So now let's look on the effects of the graph of the parent function again. This 3 is on the inside of the parentheses. Remember the formula is x minus something. Well, the only way I'm going to get a positive 3 is if this had been a -3. So this moves left 3 units. X minus 3, well, this would have been x minus something inside parentheses that would have made it a -3. It would have to be a positive 3. So this is right 3 units. X cubed plus 1 is vertical movement up 1 unit. Negative x cubed minus 5 is x-axis reflection, and it's down 5 units. For negative x cubed, this negative sign is inside the parentheses, so this is a y-axis reflection. 2 is outside of the parentheses, so this is a vertical stretch by 2. This 2 is inside the parentheses, so this is a horizontal shrink by 1/2. Remember, this is x, what's happening to x, and it's always opposite of the way we think. And the opposite of multiplying by 2 is dividing by 2. Now let's describe the transformation and graph our new cubic. This negative sign out front tells me that this is an x-axis reflection. The -5 tells me we are translating down 5 units. The domain and range will be easy because they will be all real numbers. Now let's take our key points and graph our equation. Remember, the original point is right here at 0, 0. How is it moving? Well, let's find HK. H is 0 and K is negative 5. This new point is at 0, negative 5. So this actually translated down 5 units. Now what's happening to X and Y? We've already taken care of this piece. The only thing we need to do is multiply negative 1 times Y, and all the X's will stay the same. So the X's are negative 2, negative 1, 0, 1, and 2. Remember, the key points were negative 2, negative 1, 0, 1, and 2, and the Y values were negative 8, negative 1, 0, 1, and 8. Now what's happening to X? Nothing is happening to X, but we are multiplying Y by negative 1. So all the X values will stay the same. For the Y values, we will multiply by negative 1. Negative 1 times negative 8 is positive 8. Negative 1 times negative 1 is positive 1. 0, negative 1, and negative 8. So let's graph these new points. Starting from our red dot, our new origin, out negative 2 and up 8. Negative 1 up 1. Out 0 up 0. Out 1 down negative 1. To the right 1 down negative 1. To the right 2 down negative 8. For those of you who are having a hard time with how it moves, treat the new point where the red dot is as a new origin. So from this point is now my new origin. I go out negative 2 up 8. Out negative 1 up 1. 0, 0. To the right 1, down negative 1. To the right 2, down negative 8. Let's look at the next example. I'm going to start by writing down my key points to the original. What is happening in the graph? Well, this 2 on the outside says I'm vertically stretching by 2. This 3 on the inside, since this was X minus something, this had to have been a negative 3. So we're moving left 3 units. It's the opposite of the way we think. We know the domain and range is all real numbers before we graph this. Let's find our new HK. The original started at this point. H is negative 3. K is 0. So out negative 3, up 0. This is the new starting point. This is like the new origin. From this point, I need to figure out how to move. So let's take our key points and let's figure this out. I've already used my HK, so I don't need those values anymore. Nothing is happening to X, so I'm going to leave all the X values alone. Now let's look at the Y. Y is what's on the outside, and it's being multiplied by 2. All I am looking for is how much my X and Y are being multiplied by a number, and if it's a reflection. So let's multiply all the Y's by 2. This is negative 16, negative 2, 0, 2, and 16. So from our starting point, I'm going to go out negative 2, down negative 16, which is somewhere down here. Out negative 1, down negative 2. To the right 1, up 2. And to the right 2, up 16, somewhere up here. This graph, if I just look at my new starting point, my old starting point, and my new starting point, it only moved to the left 3 units. I'm going to start by writing down the key points. What are the transformations? And let's graph. Well, the x value is being multiplied by 2, so this is a horizontal shrink by 1/2. Outside, we have a 1, so this is up 1 unit. Both the domain and the range are all real numbers. The original starting point is here, but where does the new graph start? Well, there's nothing with x, so that will be 0. The h is 0, and the k is 1. So this graph just moves up 1 unit. So let's get our new points. Each x is being multiplied by 1/2 because it's horizontally shrunk by 1/2. But I'm not doing anything to y. So all I need to do is multiply all the x's by 1/2. And now let's plot these points. From my new starting point, out -1, down -8. Out -0.5, and down -1. Out +5, and up 1. To the right 1, and up 8. You try number 4. Now let's look at 5. Starting with the parent function y equals x cubed, shift 3 units to the right. So that's going to be a -3 underneath there. So x minus 3 in parentheses. 5 units down, and reflect across the x-axis. So that's going to be in front of the function x cubed. So let's put this all together. Y equals, it is a reflection across the x-axis, so that's negative x minus 3 cubed minus 5. You try the next 3. How did you do? Now let's look at number 9 and 10. Number 9, write the equation for each graph picture below. Well, we already know this is y equals x cubed, but what's it doing? Well, if the original graph started here, it's shifting to the left 3, and it flipped over the x-axis. So it's a reflection over the x-axis. So we have y equals, move left 3, so that's x plus 3 cubed, but it was a reflection over the x-axis. And number 10, y equals, this is moving to the right 1, 2, this is moving to the right 3, so that's x minus 3 cubed. There is no movement up or down, and it's not flipping or reflecting. So that's it.